This is problem number 27 in section 3.4 about second derivative. So let's go through and talk about this. Here they want us to find points of inflection, discuss the concavity of the graph of the function. So this function here is, first off, you can look at it. You want to look at the domain of the function. You can see that it's not going to be defined if x is smaller than -3, because that'll make it negative. We're taking the square root of a negative. So it's going to be here at -3, it's going to stop right there. So we don't have to worry about anything over to the left of -3, because that would make us take a square root of a negative number. So we'll start by taking the first derivative. So I write this as y equals x times x plus 3 to the 1/2 power. So when we differentiate this first derivative, we're going to differentiate this, leave this alone, so it's just going to be 1 times x plus 3 to the 1/2 power, plus, this is the product rule now, differentiate the first function, leave the second one alone, then leave the first function alone, differentiate the second. I'm going to bring the exponent down in front, times x plus 3 to the -1/2, and when you do chain rule on this, you just get 1, so there's not much to do there. So simplifying this is going to be square root of x plus 3 plus, there's an x in the numerator right here, and then the denominator has a 2 times that radical on the bottom. So that's the first derivative. We want to make it a little bit simpler, combine these into one fraction. So I'm going to multiply by a common denominator here, 2 radical x plus 3 over 2 radical x plus 3. So we end up with y prime is going to equal that 2 over radical x plus 3 in the denominator, and that'll always be positive, where x is equal to -3, of course it would be undefined. So that would be a critical point, but it's right at the boundary. Here we're going to have, the radicals are going to cancel here. So we're going to have 2 times x plus 3. Make sure you get the 2 there, times that parentheses, plus an x. So y prime is going to end up equaling, there's 2x and an x is going to be 3x plus 6 over 2 and radical x plus 3. First derivative, the sign of the first derivative is going to be determined by the numerator, because the denominator is always positive. With a 0, it's going to be undefined, so we're not going to worry about that. But we do have to worry about the numerator here. Where is it positive, where is it negative? And you can see it's going to be positive if I make it, 0 if I make this -2. So right here at -2, the first derivative, so this is f prime, right at -2, the first derivative is going to be 0. And then if I make it more negative than that, like so right in there, -2.5 or something like that, it's going to be negative. And then if x is greater than -2, this is going to be positive, because 3 times -1 is not positive, plus 6. So over here it's going to be positive. Okay, so first derivative going up over here, going down right here. And now let's look at the second derivative. So if we differentiate this again, we can look at this as, so let me write the function over here again. Here's the first derivative, 3x plus 6 over 2 times square root of x plus 3. And I think it's probably easiest to do this as a quotient rule. So if we say this is f here, then f prime will equal 3. If we make the bottom g, then g prime is going to equal, bring the 1/2 down, it's going to cancel out, so it's going to be 2 over 2, and then it's going to be to the -1/2 power. And the chain rule doesn't really do anything, you just have to multiply by 1. So that derivative of the denominator is going to be just 1 over the square root of x plus 3. Okay, because the 2 cancels out the 1/2. So let's write this. So now we're going to do y double prime is going to be the quotient rule. So it's low d high, so it's going to be 2 times radical x plus 3. And then the derivative of the upstairs function is 3. And then minus high d low, so this is 3x plus 6. And the derivative of this function is just going to be the square root of x plus 3 in the denominator. So it's going to be like this. Okay, and then the whole thing is going to be over that denominator squared, which is going to be 4 times x plus 3, right? So when you square that radical, it goes away, but you do square the 2 and get a 4, so don't forget that. So now I think what we want to do is get a common denominator here. So I want to multiply here by radical x plus 3 over radical x plus 3. And you also want to bring this denominator down here out to the side and multiply it times 1 over 4 over x plus, and let's just write it 4x plus 12. Okay? So I think, let's see if that makes it a little simpler. Okay? So let me, let's get some space here where we can work this out, see what it turns out to be. So the radicals are going to combine here. It's all over one radical here. So this is going to be radical x plus 3 in the denominator. There's going to be 2 times 3, so there's going to be 6. And then those radicals cancel, so it's going to be x plus 3 there. And then it's minus 3x plus 6. Over there, oh, that's minus and negative, or minus the positive, so that becomes minus. And we still have, over here on the side, we still have this, let me write it as 4 times, so times 1 over 4 times x plus 3. Okay? So that's what that, this is the second derivative now still, okay? We're just simplifying it. So what happens here, let's look at the numerator. The numerator is going to become, we've got 6x, take away 3x is going to be 3x. And then I've got 18, take away 6, so it's going to be 3x plus 12 in the numerator. The denominator's got a 4 in it, and then an x plus 3 times this radical x plus 3. So that's going to be 4 times x plus 3 to the 3/2 power. This is to the 2/2 power. This is the 1/2 power. So when you combine that common base, you get it. Add the exponent, you get 3/2. Okay. So again, this denominator is always going to be positive because it's a square root here. So we're taking a square root and then we're cubing it. So the square root's going to come out positive. So the denominator is always going to be positive. The numerator is going to be positive, except, so you know, 3x plus 12 is going to be positive except at negative 4, or where it's going to have a point of inflection, where y double prime equals 0 is going to be where 3x plus 12 equals 0. So that's going to occur at where x equals negative 4. So we're restricted. We can't go, you know, we can't, the function domain runs out at negative 3. So we can never get to the point of inflection here. So what's the sign going to be? Well, as long as x is above negative 4, that numerator is always going to be positive. The denominator will always be positive. So the second derivative here, if we put the second derivative underneath, it's going to be positive everywhere, right? So it's going to be like this everywhere. So it's concave upward. It holds water everywhere. The function goes down over here and back up over there. It's equal to 0 right there. The value of the function is, if you put x equal to 0, you can see that the value of the function when x equals 0 is at 0. So I think the function looks something like this. It goes down over here, reaches a minimum right there, goes back up, and of course it keeps going up over there. It's concave upwards everywhere, so it's always curving upwards. Okay? So that's number 27. And there's not a whole lot that goes on there, but that's what happens.